Dear friends, this is our second lecture, this time on reliability, or to be more precise, item analysis in SPSS and reliability. Before we get to the SPSS part, we need to do some thinking about what's actually going on. So theory and praxis. The concept of reliability is important in educational sciences simply because we so often try to measure something that we can't grasp in our hand. We can't use a centimeter, meter, or inches or something like this to measure concepts like self concept or self-esteem or how much you like to be at school or how well you know your grammar or your maths or whatever. So we have a lot of measures that measure something abstract, something that we can't concretely grasp with our hands and see and observe directly. So we have a kind of, instead of direct observation of my hand here, I would have a concept of what I'm going to measure, and then without seeing the hand, I would ask questions, items that would give me a picture of, okay, what kind of hand is this? Okay. So we have typically some kind of understanding of what's going on from previous research and so on. And we need to define the concept that we are looking for and especially to specify which term, which name we are going to call it. So if it's a hand, then we call it hand if we know enough about it. Otherwise, we just say it's an extremity or be more vague about it. And then we need to define the concept we are after and to specify the term, yes. Okay. The definition part seems easy, but it's very, very important. And unfortunately, the more you read publications in our science, but others as well, the more often you find that there are no clear definitions, even of the most central, essential concepts. Okay. But the definition, by definition, is a very simple and useful thing. It tells us which all items or things belong to a concept and which do not. So that is a kind of essential divider or prime divider, all things that belong to the concept, all things that don't. The borderline is defined by the definition. So we have the intention is what we define, and then we have the extension of the concept is all those objects, all those items that belong to this concept. And then we simply talk about the term of the concept, which is the name of the concept. And we often encounter problems with this as well, simply, for instance, in our master's program, because we speak different languages. So when we translate self-esteem, itsetunto, självkänsla, and so on into different languages, we realize that they actually don't mean exactly the same thing. Finns are very proud that we have invented the word sauna. The term for hot baths in Finland is sauna, but of course there were hot baths long before there was Finnish or the Finnish nationality. Well, not to speak about the state of Finland. Okay. Often we realize and come to understand better understanding when we try to define and realize that in different languages we have slightly different variations of this, or maybe we don't have an exact word for it and we borrow a word from some other language and so on. So this kind of work is important, and that's the foundation of getting to grips with any concept, any abstract phenomena. So here's my picture of this. You start with some kind of an idea what you are out after. You try to define it as well as possible. So you have a rule describing the objects belonging to the concept, which is the intention or meaning of the concept in question. Here or later, you start figuring out, okay, what will we call this concept? And you can see in research literature, if you go back a little bit more, you realize that motivation was first spoken of as a broad concept, and then more specialized definitions popped up later on. So you have different types of motivation in different situations and so on. And you have the extension. So that was a target group. All those objects or cases or whatever items belonging to the concept come within this frame. And outside of the extension are all the other things, objects, ideas, whatever in the world. So green dragons do not belong to self-concept. So we'd try to define self-concept. We'd call it something, maybe self-concept. We'd have to figure out what we'd call it in different languages and so on. And then we'd say, okay, these things are typical of, these things are typical of self-concept. Here we would then have people or so on with a strong self-concept or with a weak self-concept, and so on. We'd talk about how the self-concept is visible in these people, and outside would be the rest of all things and ideas in the world, and also outside of the world. All right, reliability is seriously important, and it goes together hand in hand with another concept, which is called validity. We start out by defining what validity is. So validity is the answer to the questions. Do the items in a test or questionnaire, do the items measure the concept that we intended? So if I ask questions about my hand, which is outside of the frame here, then I will either have good questions and get a good concept of the hand, or I will have bad questions. And bad questions would be questions with low validity and reliability. If they have low validity, then I don't actually get a picture of my hand, I get a picture of something else instead. Okay, that's enough to start with. Then we have reliability, and reliability measures typically if the items in a test or a questionnaire, if they give consistent results, if they answer the same way, both if you ask different times, if you ask different persons, if you ask if you have several different ways of asking several different questions, you still get the same answer. So you have Across time, reliability would be internal consistency, so consistent over time. Between researchers would be inter-rater reliability, so whoever I ask would answer much the same about, okay, looks like this and doesn't look like that, and so on. And over time, reliability would be retest reliability. So if I ask the same questions tomorrow, I'll still get the same answers. And reliability tells us how consistently, how consistent our observations and our measurements are. Validity, on the other hand, then tells us how well the observations of the study represent that which is intended. So now we have here a picture of a dartboard, a Finnish version of it, oh well, Scandinavian version, I think. Anyway, not British. And the darts here are relatively well grouped. You could be fairly happy with that kind of a result, and also you could say that the person who gets his or her darts so close has a possibility of even improving quite easily, instead of shooting one dart here, one dart there, and some over the fence to the neighbor's side of the yard, and so on. Okay, so reliability is getting a good pack of darts, closely packed darts. Here we have items representing, we are trying to answer questions concerning Europe, and we would like to represent Europe. And here are hits are very close, so we'd say the reliability is high. But then if we want to represent the whole of Europe, and we realize that Iceland is out and Finland is out, and actually many other countries are totally out, only Germany is well represented. So these items would have a high reliability coefficient when we counted it, but it would have a very low validity in the sense that it doesn't actually represent Europe very well at all, except if the country in question happens to be a good representative of the whole of Europe. We won't get into that debate. Here again, you would have the same darts thrown much more broadly, and actually you would then conclude that you now have a high reliability, validity, because you have a good, with those countries you'd have a fairly good representation of Europe. But on the other hand, you would have a low reliability because they are so broadly out. So in some cases, quite often the situation is that you have a more fuzzy, more broad concept, or concept as Europe, for instance, with different subparts states, and then you don't want only to hit one part of it, even if that would get you the best possible reliability. So sometimes when we look for a better reliability, it is at the cost of validity, and we have to be always, this is a key idea of the whole lecture. So this you need to remember. Okay, just as a joke, here we have an excellent reliability, and the validity, well, Europe just doesn't happen to be there. Okay. We use sums or means or other combinations of certain variables, and there's a reason for that. We often combine, say, you have observations, or you have items in a test, or you have the answers in a questionnaire. and we use, as in the previous picture, several questions, several items to try to get at the essence of what is going on, the essence of our concept. And if we then count the sum of mean of these variables, then we typically get we get one score representing the whole questionnaire or the whole result of the test. So if you have a math examination, you don't want to be talking very long about each and every question in the test. You want rather to say something more general about the whole mathematical skills that these tests show. Then you would use a sum or a mean of these test items. And this is where we get close to the idea of reliability. So it's a good idea to combine items that measure the same thing, and it's definitely more problematic if they don't. So if you count the sum or the mean of say these variables, then they should start out by checking that they do correlate, so that they have something to do with each other. And I have a spelling mistake there, but the correlation, relatively high correlation between these items in one measuring one concept would indicate that they have some kind of internal consistency. So if we have, for instance, a questionnaire with 10 items on self-esteem, we don't really we go through the variation and average and so on each item briefly when we introduce the scale we are using, but we don't talk about each and every variable separately. We instead want to see how they together give us a better picture of self-esteem. And we use item analysis to measure this internal consistency, that they measure the same thing, and this produces the reliability coefficient. So we start out here, for instance, this is really just the basic idea behind it. We start out by having the items of a test or questionnaire or observations or so. So we have here the items, and our idea is that behind the covariance, so these correlate with each other, behind the reason for this correlation between the items in the test is that there's something behind it. And that's how we know that there's a hand, even if we don't see it. So the hand produces answers on these items that are similar, and the similarity gives us a picture of the hidden hand, or the latent factor or abstract factor. There are many names. We say in Finland that a loved child has many names. Okay, here the latent factor, or just factor among friends, causes the correlation between the items. So we have different types of scales. One typical way of getting at these factors is using questionnaires, measuring attitudes. And typically we use a Likert or Likert scale, depending on who's saying it. Let's call it Likert scale. It would be something of the kind of I strongly disagree, I strongly agree, or variations of this, but they would measure the attitudes of those who answer the question. Now, if we are very strict, we would say that these are on an ordinal scale. You remember from last time that then we wouldn't say that the difference between 3 and 4 would be the same as that between 1 and 2, for instance, the distance. But they certainly are in some kind of an order. So strongly agree is more in one end of the scale than strongly disagree, and the others fall in between in a certain order. If we just stay with the ordinal scale, we don't get very far. Most statistical methods are actually based on interval scales. There are non-parametric variants of these, and we'll get into those as well. But the idea is that we have interval scale measurement and normal distributions mostly. That would be a good starting point. We often in education treat Likert scale items as if they were interval scaled. It helps actually if you look at this here, if you don't name each and every one of these categories in between. So I strongly agree, I agree, I rather agree, I rather disagree, and so if you give names to all of these, then you go in the direction of making it not interval scale but strictly ordinal scale. However, we have results that also indicate that even if you ask kids, for instance, at school, they still answer as if the scale was more or less interval scale, even when you have given the names of the categories. Okay. Now, combining the results of several items which correlate typically gives us a more clear picture of the whole concept that we are interested in, and often mostly this is more interval scaled than the separate items that go into it. Often we also come to see that the differences between exactly how a certain item measuring something is formed, the differences they equal out. So instead of having one variable that is slightly to one side and lopsided one way and another in the other direction and so on, when you put them together, you get a really nice, often get a quite nice normal distribution. If you have a little bit more items, it's even easier to see. So the specific details of the items cancel each other, and you end up with some kind of the essence of what the questionnaire or test is all about. Okay, we need to say something about multidimensionality. Also, we get into this in the next lecture concerning, which is about factor analysis. But in education, our concepts very often are multidimensional. Well, the example of Europe also told us that in most ways, if you look at Europe, it is also multi-dimensional. But anyway, then we would be interested in what are the central dimensions, and is there previous research which would kind of give us an indication of which type of dimensions we could find there. And sometimes we just use factor analysis to realize how many factors there are in a field that hasn't been studied yet. Okay, so that's peel away is hidden or latent factor. So we'd kind of have the difference between these two models is that here you would be explaining the world using one factor, and it would be an adequate fit. Here again, you would have a different situation. So you'd have some items that would be measuring well one dimension, and others would be measuring well another dimension. Okay, so the first situation, this one is where we use item analysis. The second is where we use typically factor analysis. And we can, of course, make the second variation also. So if we just take the first three items, then we would be back in a situation with one factor. So we could item analyze this and get the reliability of it as well. And so then we could do a second item analysis with this here. Okay. Getting more serious, real stuff. So school burnout is a syndrome that Katarina Salmelaro at our faculty and others have studied for a long time. It's kind of stress in school, and they have analyzed this to find the three dimensions. So exhausted tiredness, just as with adults in work life, really tired. But another dimension that often goes together or correlates with this, but is not the same, is cynical attitude to school and studies. You could convert this in work life to cynical attitudes to the workplace and its demands. So in some case, often it is, these go hand in hand, but not always. So you can have people who are very cynical, kind of protecting themselves from something that they don't want to be so important because they have become already previously exhausted and don't want to get to feel that way again. So they are being cynical to protect themselves. And you have feelings of inadequacy as a student. Again, similar to being inadequate at the work you do. So it's a nasty feeling, and certainly you want to become a little bit protective of yourself so as not to feel too hurt by being inadequate. And there's a school burnout inventory, and it has been used in primary, secondary, and tertiary education. I'll show something of it here. So here we have a set of three factors, three latent variables. It was you remember the exhaustion, the cynicism, and the inadequacy. And there are then a set of items for each of these three factors. And also this is a way of just showing that not only do the items correlate, but also here the factors correlate with each other. So the exhaustion, cynicism, and inadequacy, they have something to do with each other. They correlate. Otherwise, there would be a point in calling it a school burnout general concept, school of burnout, it would be one thing, the other, and the third separately. Okay, we'll get back to this, I promise you, in our next lecture. So we dive more deeply into reliability analysis. So reliability analysis is one way of calling it, and item analysis is the program that is used in SPSS for this. Okay, so the foundation, the basic, the whole thing that this work stands on is combining, combining items that measure a concept, and it comes from either from the theory of the thing that we are looking for. If there is a theory, usually you find some kind of indicators, but not always very well thought out and well worked. So we will learn methods of handling these situations. Then we get into the question of internal consistency. So it is important, if we say that the items measure the same thing, that they actually do correlate. They in this way indicate that they have in practice something to tell about the same phenomenon. And for this we use the item analysis, which gives us the reliability coefficient. Okay, looking up from different sources, reliable means dependable, authentic, sound, trustworthy, unwavering, constant, unfailing, truthful, honest, secure, and a lot of other words. But they all have something in common. They are talking about the same thing. That we can depend on, we can measure, and the results will be trustworthy, unwaveringly give us the same result different days, constant in this way, truthful. Okay, and we can feel secure about the result. So in quantitative research, we use reliability typically to tell us about how well the items in a test or questionnaire go together, how internally consistent they are. Do they measure the same thing? And for this, we have an indicator, the reliability coefficient. We call it alpha. The longer name is Cronbach's alpha. There are others as well, but this is a good one. It actually gives us kind of the underestimate, so lowest estimate of the reliability. So the real reliability of the items is above it. If the level of reliability is already fairly high with the Cronbach's alpha, then we can say that we are happy with the situation, because we won't get a situation where the real reliability would be lower. So it's an indicator, a coefficient that gives us a result that is secure. And it typically measures the internal consistency of the items. It's based on the correlations between the items. and also on the number of items we have. So if you want to make a questionnaire or test with a better reliability, higher alpha, then the typical way is to, first of all, to check if we have bad items in the set. So if we leave out the bad ones, it improves the alpha. We can also add more items to the test, and that will also heighten the alpha. And the third thing we can do is take a closer look at those items that don't have such a good reliability. Sorry, that are not so strongly correlated with the other items, and think about, are they important from the perspective of validity, or should we change the wording, for instance, make them clearer and more understandable to the people who we are testing, and that might also increase the reliability. There's one thing we need to be aware of before we start, and that's the direction of variables. The item analysis is a fairly old-fashioned program, so it doesn't do things that we kind of would expect it to do. In some cases, we have items, and people often say even that it's a good idea to have questionnaires with items that have different directions. So you could have items asking, am I tall? Yes, no, I'm not very tall. So, but you could equally well approach the same thing, length, by asking, are you short? Now, one would be kind of positive. So the high values would indicate that you have a lot of length. The low values would indicate that you are short, will not have a lot of length. But the shortness item would be exactly the opposite. So the more you say that, no, I'm not short, the taller you probably are. These two would typically have a correlation that would be fairly strong because they measure the same thing, the same understanding of the person, but they would have a negative correlation. Now, what to do with this? The typical way of fixing the situation, because the item analysis tilts when you put something like this in, it doesn't work. Typical way of fixing it would be to change the direction of the negative items. Okay. So if you have something like, I'm a fast learner, I like to learn new things, and all new learning is difficult for me, then the last one is clearly measuring the same thing, we think, but it's negative compared with others. So we need to change that direction. And if it has, for instance, a scale of 1 to 5, the easy way to do it is create a new variable out of it, where you take the you subtract the result, the score that the individual has. You have put a 3 there. You subtract that from 6. So if you have a 3, then you get a 3. But if you have a 5, you get a 1, 4, 2, 3, 3, 2, 4, and 1 would become 5. So you change the direction of, in this case, then all new learning is difficult for me. You could put a small minus after it, and that would indicate now we have changed the direction. I also did a quick search to see if you can find some stuff on the YouTube on item analysis with different approaches, and you certainly can. And there's plenty of them. 23,000 is more than enough for most people. In many cases, you can see from the number of views and also comments that they are actually pretty good as well. All right. How do you go about this? We start out with SPSS. We go to analyze, scale, and from there we find reliability analysis. So it's fairly direct. So analyze, scale, reliability. What pops up is this. And here you can select from the variables you have those that you are interested in analyzing. So here I have put items that have something to do with the way the students think that their parents support their engagement in school. Okay, this is just what the SPSS produces. First, the kind of memory lane tells you that you are going to analyze. You use scale and reliability, select reliability analysis. Well, that's what we just did. Then it tells you which items you choose. After that, you get to the point where you can choose the model, which typically in our case is alpha. So it's Cronbus alpha. And then if you want to have other statistics to describe the variables, then you choose all descriptives also. That's recommendable. And then you get already the result. Here, the essential thing pops out as the first. So it gives you this small table here with Cronbus alpha and the number of items that we have in here. So what would we say here? Well, we could say that the Cronbus alpha is quite high, and so these items about how the student feels about their parent support for their studies, they are internally consistent. We can even say that they are highly internally consistent. They have a high reliability. The next thing we need to think about, okay, the sufficient reliability. Some reliabilities are good for one thing, some for another. Now, we typically would probably continue to check the differences, but use this the result of this would be used to check if, for instance, the girls and boys feel the same about their parents' support. And maybe if there's a connection between this support of the parents and the test results and grades of the student. That would be group level, so boys, girls, group level analysis, or all the students correlation this with that. If we have a group level analysis, like a t-test, it already tells us the significance of the result. So if you have you can have a relatively low Cronbus alpha and still be quite okay with the results that you then produce with this scale. So 0.7 would be quite nice. Even a little bit lower is quite okay. But if you are going to be a psychologist or in educational assessment have decisions, make decisions concerning individuals. So this student should be selected into our program, that student should not be selected. Then you should have much higher alpha. So 0.9 would be appropriate. That means much longer tests, and they would be naturally much more tiresome for the students. So you can't measure so many things with such high alphas. Now then, if we look more in depth at the results, you remember that we selected the Cronbach's alpha. That's the same we already had there. But then we have this really nice table with the item total statistics. So they tell us especially what happens if you have these, sorry, try to find my way here. If you have these items, then what would happen if I leave out a certain item? Would the Cronbach's alpha become better or worse for it? And if you start out here with the Cronbach's alpha of 0.882, then it's fairly clear that you actually end up with worse items, with a worse set of worse test if you leave out one of these items. And you can also see it by looking at the correlations here. The correlations are, well, this would be the weakest of them, but it's still a fairly high correlation. So no reason to drop any items out according to this analysis. If, however, you decide to leave out, you have a low correlation, that would result in a much better alpha. If the item is dropped, then you need to do a new item analysis. So you just drop it from the previous, and then you can see in the Cronbach's alpha what it really became. Now then, we have a second example with a totally different situation. So here we'd have a fairly okay Cronbach's alpha still. I mean, that's not horrible at all. For group testing, that would be quite fine. But now if we take a look here at what would happen if we would drop just the last item, you realize quickly that that would be a very good idea. So you'd end up with this, exactly the same set of items that we just had. The third one, the last one is simply doesn't belong to this test. And you can see it also if you look at the correlations of the items. Sorry. So here you'd have the correlation with of a variable with itself is always 1, but you can see that these would correlate fairly highly, and then the correlation with the last one would be low or non-existent, even negative. So that's typically why we would not even get a better result if we change the direction. We have 4 in one way and 1, but it doesn't correlate a lot, so it doesn't help to change the direction. It would slightly improve, but not much. The best way is just to toss it out, and then you would have a good test. Okay, this looks horrible, but it's not so dangerous. It is what can you do? to do with the drunken sale. What can you do with them after the item analysis? Well, you remember that we were talking about producing new variables. So you don't have to use each and every one of the items. You can put them all together. How to do that? And a typical good way of doing, that would be to go here. So we were just in analysis. Now we go to transform, compute variable. And there we would start out by finding statistical functions, or you can look at all the functions, but statistics would give us then this most important part would be mean or sum. If you select it, then it pops up here. Now you would already have the basics of the idea. Then you just put in the variables that you are interested in. So you select the variables over here, and you get them in here with a comma in between. So that would be the mean of the 4 variables that we have been interested in. And those together would be mean parent attitude. So we give a name for the new variable that we are creating. Okay. Compute. Find the correct or most useful function and select the variables into it. That's the idea. That's what it looks like when you press OK. And oftentimes you end up, as I said, with a sum or mean variable that has a nice normal distribution and so on. However, that is not the case with these variables. So you can clearly see that there are 2 peaks here, different combinations of 3 and 4, and very few of 1s and 2s. So it's a very skewed distribution with 2 peaks, not really nice from the perspective of continued analysis, but with a very high reliability. So you can't win them all. All right, here I have, even though we had this non-normal distribution, I have now just demonstrated what you can do. So we have one variable here with the support of parents for schoolwork, and then you can have, here we have the different levels of education of the parents, highest educational level of the parents, and you can see that there is a significant change between the groups, so that those parents with the highest education are conceived as having the strongest support for the students' schoolwork. So how do you report this result of the item analysis? Well, you can either tell about the reliability finding Cronbach's alpha in the text or as a separate table, which you refer to in the text. It is advisable that you describe which items you are including into the analysis. If you leave some out, then and that improves the reliability, then good. But you also tell that, so that for instance, people who want to improve the test that you are using or the questionnaire you are using, they get the message that don't use these items as such, they are bad, but if you change them in this and that way, then you could get a much better test. So that would be kind of helping each study kind of building our understanding, so we become small, sooner or later end up with a real strong big picture. Here's a really impressive way of describing the results. So we have a table where the Cronbach alpha is expressed for all the tests that they have used here. You would have the average and the standard deviation of each test. You would have their skewness and kurtosis, and you would have here their alpha. You would also have the correlation between these different tests. So that would give the reader a really powerful understanding of what's going on. So this would be really impressive if you do it. You could leave out the skewness and kurtosis and just talk about it, and you can easily, of course, have just the mean and standard deviation and the alpha in one table and another table with the correlations. So you don't have to have everything in the same. There's not just one way of reporting it. You can do it this, you can do your way. Thank you very much.